We'll take the second problem on perceptron. The second problem is a Boolean function, that is the OR Boolean function. So you people are familiar with the truth table of the OR Boolean function. So we'll take the truth table as the input and we'll see how to learn the weights for the OR Boolean function. Now, given the question is, consider a perceptron to represent the Boolean function or with the initial weights. The initial weights given is W1 equals to 0, W2 is 0, B is 0, that is bias, learning rate is 0.1, and the activation function is the step function. The step function, if we are using, it is +1 and 0. +1 when the threshold value is greater than or equal to 0, and 0 when it is less than 0. So this is the step function we are going to use instead of the signum function. So with this, we need to design a perceptron that performs the Boolean function or, sorry, this is OR, and update the weights until the Boolean function gives the desired output. So this is the truth table of what? Of the Boolean function, that is OR. So you know when it is 0, 0, it is 0, 0, 1, it is 1, 1, 0, it is 1, 1, 1, it is 1. Fine. Now from this, if x1 and x2 are the inputs, so this is my target value or the target output, that is nothing but this is T. Fine. Now we need to learn the weights of this perceptron because, or the learn the weights of this OR function, because W1, W2 and bias is what we have assumed with the small random values. We'll see how to learn the weights now. Fine. Now, given the initial parameters, this, if I just write the diagram for a perceptron, this is how it looks like. So we have the input x1, x2. It can be either 0 or 1 because we have a truth table with 4 different sets of input. Then W1, W2, then the bias value. Then we have a step function, that is the activation function. Then finally, the obtained output. So the obtained output is equal to the target output. Then we'll get the output here. Otherwise, we are just going back and we are adjusting the weights or we are learning the weights. So this is how we can just represent the values with the help of what? The perceptron or a single neuron. Now we'll start with the epoch 1. So I'll consider the epoch 1 and we'll see how to learn the weights of what? The OR Boolean function. So now first what I'll do, I'll consider the first instance. So the first instance we have is what? 0, 0, which is nothing but this is x1 and this is x2. So we have the bias value, weight, as well as the learning rate. So when we consider this, now first do the summation, that is w1 into x1 plus w2 into x2 plus the bias value. So which is nothing but this is 0 into 0 plus this is 0 into 0 plus the bias is 0. Hence the weighted sum value is what? That is 0. Fine. Now this weighted sum value has to be sent to where now? The activation function. So the activation function we are using is the step function. So it is 1 if what? If the output is greater than or equal to 0. Fine. Otherwise it is 0 if it is less than 0. Now what we have here, it is 0. Fine. So once it is sent to the activation function, what I'm going to get, since it is greater than or equal to 0, the obtained output is what? So obtained output is what? It is 1. Fine. Now this obtained output, fine, is not equal to the target output, because when the input is 0, 0 for the OR function, the output we are going to get is 0. So this is my target value or the target output, but the obtained output is what? That is 1. Fine. So what we have, that is 1, which is greater than or equal to 0. So I can tell which is not correctly classified. So it is not correctly classified. So if it is not correctly classified, because T minus the obtained output, that is O, is not equal. So what we'll do is we'll try to update the weights and what and the bias value. So how to update the weights now? So we'll update the weights. So I need to update the weight W1, which is equal to W1 plus the learning rate, the target output minus the obtained output into X1. How to update that value? W2. W2 is W2 equals to W2 plus the learning rate, again the target output minus the obtained output into the second input, that is X2, and the bias value B equals to B plus again the learning rate, the target output minus the obtained output into this is X naught, where X naught is always equal to 1. Now substitute the values here. W1 is 0 plus the learning rate is 0.1. So T is what? The obtained, the target output. The target output is 0. What is the obtained output here? Obtained output is 1 into X1. X1 value is what? So this is X1, this is X2. So it is 0. Now what is the weight of the W1 now? It is 0. Now coming to W2. So again it is 0. So this is 0.1. This is 0 minus 1 into 0. The weight of W2 is what? That is 0. Now coming to the bias, it is 0 plus 0.1. So this is 0 minus 1 into 1. So what is the answer I'm going to get? So it is 0.1 into minus 1 minus 0.1 into 1. So it is minus 0.1. So what is the updated weights we are going to get? So the updated weights we got is W1 is 0, W2 is also 0, but the bias value from 0 has been changed to minus 0.1. Right? Now with this, what we'll do, we'll consider the second instance. Now consider in the epoch 1, we'll consider the second instance. The second instance is 0, 1. Okay. What is the target now? It is target equals to 1. It is nothing but whenever in the OR table or in the OR Boolean function, when the value is 0 and 1, it is always 1. So this is my target value. And the updated weights we have is W1 equals to 0, W2 equals to 0. Then finally, okay, the bias equals to minus 0.1. Correct. Now with this, what we'll do is, fine, I need to find the weighted sum plus W2 into X2 plus of bias. So it is 0 into 0 plus it is 0 into 1 minus of, okay, bias value is what? It is 0.1. So what is the answer I'm going to get? It is minus 0.1. Now this is sent to where now? The activation function, that is the step 1 function. Fine. So minus 0.1 is less than 0. If it is less than 0, what is the output I get from activation function? It is 0. But the target output is what? That is 1. But the obtained output is what? That is 0. Hence, not correctly classified, because the obtained output is 0, which is not equal to what? The target output. So since these two are not equal, what we need to do now? We need to update weights and the bias value. So we get W1 equals to W1 plus again into, X1. Then update the weight W2 equals to W2 plus E minus O into X2. Then update the bias value. Bias value is into X naught. So this will be equal to 0 plus 0.1 into 1 minus 0 into 0, which is equal to what? That is 0. W2 equals to, okay, 0 plus 0.1. The target output is what? That is 1. What is the obtained output? Obtained output is 0 into X2 is what? That is 1. So what is the answer I'll be getting? It is 0.1. Bias is what? It is minus 0.1 plus this is 0.1. Then 1 minus 0 into 1, which is equal to minus 0.1 plus 0.1. So finally, what is the answer I'm getting? 0. So we get the new updated weights. So what I have, W1 equals to 0, W2 equals to 0.1 and bias equals to 0. So these are what the new updated weights. Now with this, what we'll do is we'll take the third instance now. Now consider the third instance. Now the third instance from the truth table is what? 1 and 0, that is x1 and x2. When we take OR function, when it is 1 and 0, the target output is what? That is 1. Fine. Now we'll try W1 into X1 plus W2 into X2 plus the bias value. So the new updated weights are what? W1 equals to 0, W2 equals to 0.1 and bias equals to what? That is 0. Substitute the values in this. So find the weighted sum. So it is 0 into 1 plus 0.1 into 0 plus it is 0, which is equal to 0. Now this has to be sent to where now? The activation function. So since 0 is greater than or equal to 0, what is the output we are going to get? It is 1. Fine. Now whenever we have OR operation, when it is 0 and 1, we are getting 1. So this is my target value. So this is my what now? Obtained output. Fine. Since the obtained output is equal to the target output, so it is correctly classified. So no need to update the weights. So what we'll do, we'll consider the next instance, that is the last instance from the truth table, which is 1 comma 1. When it is 1 comma 1, the target t equals to what? That is 1. Fine. Now we'll just find the weighted sum, w1 into x1 plus w2 into x2 plus b. So what is w1 now? It is 0 into x1 is 1 plus w2 is 0.1 into 1 plus it is 0. So we get the answer, that is 0.1. Fine. Now this 0.1 is sent to the activation function. So 0.1 is greater than or equal to 0. Hence, what is the obtained output? Hence, obtained output is what? Is equal to 1. Now this obtained output is equal to the target output, because when OR function has 1 and 1, it is 1. So this is my target value. So since target value is equal to the obtained output, there is no need to what? Update the base, because it is correctly classified. Fine. So this completes by what? Taking all the instances from our table. Now what we'll do is with the new updated weights, it is classifying the third instance and the fourth instance, that is correctly. Now for the same weights, we need to check whether the first and the second instance, even they are working fine. So what we'll do is we'll start with the epoch 2. Epoch 2. Fine. Now after epoch 1, what are the updated weights we have now? That is W1 equals to 0, 0. W2 equals to, it is 0.1, and the bias value is what? That is 0. Learning rate will be as it is, that is 0.1. Now we'll take this value and we'll start with the epoch 2, that is the second iteration. Now consider the first instance again, that is the first value from the OR truth table. So it is 0, 0. When OR value is 0 and 0, the target t is equal to 0. Now take w1 into x1 plus w2 into x2 plus b. So it is 0 into 0 plus 0.1 into 0 plus the bias is 0.0. It is nothing but 0. When it's sent to the activation function, since 0 is greater than or equal to 0, what we get? The obtained output from the activation function is what? That is 1. Fine. So this is not equal to the target output, that is 0. Hence, not correctly classified. So it is not correctly classified. So what we need to do now, we need to update the weights. So it is W1 equals to W1 plus T minus the obtained output into X1, W2 plus the learning rate, T minus obtained output into X2, then B equals to B plus the learning rate, target output minus the obtained output into X0. Substitute the values now, you will get 0 plus 0.1 into this target output is 0 here. It is 0 minus 1 into 0. W2 is 0.1 plus 0.1. Okay, 0 minus 1 into 0. Then the bias value is 0 plus 0.1, 0 minus 1 into 1. So I'll get the updated weight. It is 0, which is equal to 0.1, and the bias value equals to minus 0.1. Fine. Now with this, what we'll do is the new updated weights are. So W1 equals to 0, then W2 equals to 0.1, then bias equals to minus 0.1. Now we'll take these new updated values and we'll take the second instance from the epoch thing. So the second instance, that is when it is 0 and 1, fine, the target T is what? The OR operation value is 1. The new updated values are W1 equals to 0, then W2 equals to 0.1, and bias equals to minus 0.1. So what we need to find? We need to find the weighted sum, W2 into X2 plus B. So it is 0 into 0 plus 0.1 into 1 minus of 0.1. So which is equal to 0. Since 0 is greater than or equal to 0. So what we are going to get? We get the obtained output as 1, that is 1. So hence correctly classified, because the obtained output is equal to this target output. So no need to update the weights. What we'll do is we'll take the third instance now. So when we get third instance, it is 1, 0. When it is 1, 0, the OR function outputs the value, that is 1. Fine. Now update the weights now, that is W1 into X1. So what we'll get now? It is 0 into 1 plus 0.1 into 0 minus 0.1. So what is the answer we'll get? It is minus 0.1. Since check this, so minus 0.1 is less than 0. So what we are going to get now? Hence the answer is 0. The obtained output is 0. So this obtained output is not equal to the target output. So not correctly classified. So what we need to do now? We need to update the weights. So when you update the weights, what we need to do? W1 equals to W1 plus into T minus 0 O into X1 plus W2 equals to W2 plus the learning rate, the target output minus the obtained output into X2 plus bias equals to B plus the learning rate, target output minus the obtained output, that is O into X0. Substitute the values. So it is 0.1, then 1 minus 0 into 1. What is the answer I get? It is 0.1, which is equal to 0.1 plus 0.1, then 1 minus 0 into 0, which is equal to 0.1, which is equal to minus 0.1 plus 0.1 into 1 minus 0. X0 is always equal to 1. So the answer I'll be getting is 0. So hence the updated weights or the new weights is what we'll get is W1 equals to 0.2, W2 equals to 0.1, and the bias value is what? That is 0. Now we'll take this new updated weights. Then what we'll do is we'll take fourth instance. So what are the new updated weights we have now? That is W1 equals to 0.1, then W2 equals to 0.1, then bias is what? Bias is 0, 0. And you take fourth instance, we have x1 as 1, x2 as 1. So if both are 1, 1, then the target t value is what? That is 1. Now find the weighted sum, W1 into x1 plus W2 into x2, sorry, plus the bias. W1 is 0.1 into x1 is, this is x1, this is x2. So 1 plus, it is 0.1 into 1 plus the bias value is 0. So what is the answer we'll get? It is 0.2. So since 0.2 is greater than or equal to 0, okay, what is the obtained output we'll get? So obtained output is 1. So which is correctly classified. Why? Because this target output is equal to the obtained output. So what we have considered all the four instances. So after epoch 2, this completes with epoch 2. So we have the weights. So W1 equals to 0.1, then W2 equals to 0.1, and bias equals to 0.0. Fine. Now again, we need to take this and go back and check whether it is same for all the four instances without any changes in or the updation in the weights. So we'll start with what? The epoch 3. Epoch 3. What are the new updated weights from the previous epoch? It is W1 equals to 0.1, 2 is 0.1, and the bias is what? Bias is 0, 0. Now again, we'll start with the first instance. Okay, the first instance from the truth table is 0, 0. When x1 is 0, x2 equals to 0. So target t equals to what? That is 0. So find the weighted sum, W1 into x1, W2 into x2 plus the bias. So W1 is what? 0.1 into 0 plus 0.1 into 0 plus the bias is also 0. What is the output we'll get? 0. When you send this to the activation function, 0 is greater than or equal to 0. So hence, what we get the obtained output, it is 1. So since this 1 is not equal to the target output, not correctly classified. So what we need to do now? We need to update the weights. Fine. Now when we update the weights here, so what will happen? We need to update W1 equals to W1 plus target minus obtained into x1. Then W2 equals to W2 plus the learning rate, the target minus obtained into x2. Then bias equals to bias plus the learning rate, target minus obtained into x0. Substitute the values and find the new weight. It is 0.1 plus the new, the learning rate is 0.1. Target is what? 0. Obtained output is what? 1. So 1 into x1. What is x1? x1 is 0. Then W2 equals to W2 is 0.1 plus 0.1. Target is 0 minus obtained is 1 into 0. Then bias equals to, it is 0 plus 0.1. Target is 0 minus obtained is 1 into 1. So what is the answer for weight? It is 0.1. W2 it is 0.1, and bias we are going to get as what? Minus 0.1. So the new updated weights are what now? W1 equals to 0.1, W2 is also equal to 0.1, and bias equals to minus 0.1. Now with this, what we'll do? We'll go and we take the second instance, and we'll see whether the second instance is working fine with these weights. Otherwise, we need to update. We'll check that. So with the third epoch, go to the second instance. Fine. The second instance, when it is 0 and 1, the OR function outputs the value what, that is 1. The new updated weight from the first instance, W1 is what we get updated weights as 0.1. This is 0.1 and bias as what, minus 0.1. Now second instance, x1 is this, x2 is this. So we'll calculate W1 into x1 plus W2 into x2 plus the bias. So this is W1 is 0.1, x1 is 0 plus 0.1, x2 is 1 plus bias is minus 0.1. So what is the answer I'll be getting? It is 0 because plus 0.1 minus 0.1 is 0. So when I send this to activation function, 0 is greater than or equal to 0. Hence, what is the output that is stored got from the activation function? It is 1. Now this is the obtained output. Obtained output is equal to the target output. So it is correctly classified. So no need to update the weights. So we'll see whether the new updated weights work fine for the third instance. So consider the third instance when it is 1, 0. The OR function outputs t equals to 1, the target output. So W1 into x1 plus W2 into x2 plus the bias value. W1 is 1. So W1 is 0.1. X1 is 1 plus 0.1 into 0. Bias is what? Minus 0.1. So what is the answer we'll be getting? It is 0. So when we send this to the activation function, 0 is greater than 0. So hence the step function gives the answer as what? That is 1. So it is correctly classified because the obtained output is equal to the target output. So even these weights are working fine with the third instance. Now I'll consider the fourth instance, that is 1, 1. When it is 1 and 1, the OR function outputs the value that is 1, which is the target output. So calculate the weighted sum, W2 into x2 plus b. So W1 is 0.1 into 1 plus 0.1 into 1 minus of 0.1. So what is the answer I'll be getting? 0.1. So when you send this to the activation function, 0.1 is greater than or equal to 0. Hence, obtained output is what? Output is what? Is equal to 1, which is correctly classified. Fine. So the new updated weights are correctly working for the second instance, third instance, and the fourth instance. So in the next epoch, we'll see whether even these weights they're working exactly fine for the first instance. So what we'll do is we'll start with epoch 4. So what I'll do, I'll consider the first instance of the OR table, that is when it is 0 and 0. The OR function outputs what? That is 0. Calculate the weighted sum, W2 into x2 plus b. What are the updated weights from the epoch 3? That is W1 equals to 0.1, W2 equals to 0.1, and bias equals to minus 0.1. So substitute the values in this. So it is 0.1 into 0 plus 0.1 into 0. Bias is minus 0.1. When you give this to the activation function, minus 0.1 is less than 0. Fine. Whenever it is less than 0, the step function output 0. So hence, obtained output is what? Output is 0. So this obtained output is 0. The target output is 0. So it is correctly classified. So no need to update weights. So correctly classified. Okay, so already we have checked for the same weights in the previous epoch. The second instance is classifying correctly, third instance is classifying correctly, fourth instance is classifying correctly. So no need to again calculate this. So directly tell. So for the same weights, second, third, and fourth is classifying correctly. So weights are not updated, not updated, not updated. So the final weights, the final weights or the learned weights for or function is what finally we are getting. W1 equals to 0.1, W2 equals to 0.1, then B equals to minus 0.1. So these are the final updated weights. Now with this, we'll have a boundary equation. So hence, we have the boundary equation, that is that we have W1 into X1 plus W2 into X2 plus bias value. So every time this X1 and X2 keeps changing, so we need to fix these three values. So W1 is fixed now, it is 0.1, X1 you keep as it is, W2 is 0.1, X2 as it is, bias is minus 0.1. Now for these three values, you give any input values of X1 and X2, it is going to exactly perform the function of what? That is your or Boolean function. So this is how we are going to train the perceptron and learn to adjust the weights and finally come up with the boundary equation. So this completes with what? The or Boolean function for the given initial weights, and this is the final weights that we have got. In the similar way, you can also perform the operation for the AND, NOR, NAND, and other Boolean functions. Thank you.